Great, thank you. Next up, we have Team Kulisha. We're going to hear from Eric. Welcome to the stage.
Thank you.
So Eric, you're from University of Michigan, but you're actually from Grand Rapids.
Yeah, I'm back home. It's great being back here in this cool city and being able to pitch in my hometown. It's really exciting.
It's like home court advantage.
Yeah, I know.
You have like family here today?
So I actually thought they were going to be here, but it turns out my sister is getting senior awards today. So she gets priority at Forest Hills Northern High School. But they did say they would come to the award ceremony, so I got that going for me.
Great. So tell us a little bit about what you're going to present on.
Yeah, so basically what we're trying to do is create a waste solution that enables small-scale waste producers to turn their waste into value, and that value is a high-quality, sustainable protein source.
Excellent. Look forward to it.
Thank you. Thank you. Cool, so hi everybody, I'm Eric. Thank you for being here. I'm here to present our idea Kulisha, our venture Kulisha. And I'm really excited to go right after Eco returns because she just did such a great job of explaining the issue with overfishing. So I don't have to go as much into it, but just to be repetitive real quick, 90% of fish stocks are overexploited or depleted. And you just heard about many of the issues associated with that. But what you may not know is that 40%, almost 40% of all the fish that we take out of the ocean are actually used as a protein base in animal feed, which is astonishing that 4 out of every 10 fish that we use are actually used to fuel the agricultural system, and then we consume that livestock. Now, at the same time, in the United States, we throw away 36 million tons of food waste every year. Now, just to put that into scale, if you were to put every single American on an enormous scale and you were to double that weight, that's how much food waste we throw out on an annual basis. So of these huge two conflicting problems on various sides of the spectrum, on one side, you're taking this precious and rare resource from the ocean to extract protein from it. But here in America, we're throwing away millions of tons of the same resource. It's a huge issue, but it's also really exciting because there's an enormous opportunity to create a circular economy there. The big question is lots of this food waste goes bad quickly. So how can you capture that value, capture the value of the protein, store it, and then use it as a protein base? And so we were thinking about this solution and realized that there was already a solution to this problem, and it's called the black soldier fly larva. It's an incredible insect. It's one of the world's most efficient converters of organic waste into protein. It grows over 5,000 times its size in just its 2-week larval life cycle. Additionally, it has a complete amino acid profile and has been shown through studies to be an efficient replacement for fish meal. And finally, this insect is a little different from most insects in that it's not a vector for disease. So it's actually the first insect to ever be approved for commercial animal feed in the United States, the EU, and in Canada. So we have this solution. So we decided to focus and really dive in to food waste a little bit more and understand how can we find a way to bring this solution to existing people that have the problem. So we looked into food waste and found out that industry, unsurprisingly, is one of the largest producers of food waste, dumping millions of tons of this organic waste every year. So we really did a deep dive into different industries and decided to focus on the brewing industry. They're throwing away some of the highest volumes of organic waste of any industry. And it's really important that their waste is extremely high value. It's very high protein, it's all grains, it's homogeneous, it's consistent, it's an ideal feedstock. But what we found is that large breweries, like extremely large ones, Anheuser-Busch, Molson Coors, are doing a pretty effective job of getting rid of their waste sustainably. Because they're so large, they have the resources and they're able to commit that time and energy to finding those sustainable alternatives. But the gap is in microbreweries. So microbreweries are producing pretty small scales of waste, between 300 and 700 tons a year, so they're actually not able to access those existing solutions. However, they're still pretty large waste producers. They're just not being reached by the existing infrastructure to sustainably get rid of their organic waste. What we're doing is we're creating a solution where we can actually bring the insects to the waste producers, turn their organic waste into value by growing the larva on the waste on site. And before I go into exactly what our solution looks like, I first want to talk about that there are actually other people that are doing black soldier fly growth on on organic waste. But they're taking a radically different approach. They're essentially acting as a waste manager. So they have trucks, they have a huge facility, requires land, heavy investment in capital. They truck all this waste within a 40-mile radius, only a 40-mile radius, to their facility, and then grow black soldier fly, taking it through the entire life cycle. Now what we do is we've created a revolutionary and proprietary shipping container solution that only handles the black soldier fly at the larval life cycle stage. What we do is we can put this shipping container on their site, interface with the existing infrastructure of the brewery that they're currently using to dispose of this waste, move the waste directly into the container, and grow larvae on site. And something that's really exciting is we're targeting microbreweries right now, but this solution can be scaled to other organic waste producers throughout various industries and really help create a circular solution to a huge problem. So what this looks like is it costs about $50,000 to build one of these containers. But you're able to generate larvae within this container, and you can achieve about $16,000 per ton for these larvae. Now, each container can generate about 40 tons, leading to annual revenues per container at just over $600,000 per year. Something that's really exciting is through our conversations with these microbreweries, they're extremely excited about this solution and willing to adopt it. Lots of these microbreweries are owned by small business owners that are very conscious, they're innovative, and they're conscious of what their business is doing to the environment. And not only that are they looking for more sustainable alternatives to their waste, but we're actually able to incent them. So by us taking this approach where we're developing this modular solution that we can come to them and use their existing infrastructure, we can save money and pass that along to them. So they can view sustainable waste disposal as not just an alternative, superior solution for the environment, but also as something to generate additional cash flows. So again, I just have to say how excited I am to be back here in my home city of Grand Rapids. I really love it here, and it's really cool coming from the city because this kind of inspired this idea. So many microbreweries around here. There's a huge opportunity, and this would be an awesome city to take this back to. But how this idea really started was I met my co-founder, Viraj. You can see him up there. But we were both part of the Doris Duke Conservation Scholarship Program, which is an incredible program, really similar to Wege here, in that the goal of it is to bring a diverse and interdisciplinary approach to conservation problem solving. So they brought a diverse group of students from all different backgrounds to come together to try to create the future of the conservation workforce. Now, I worked for an economic development agency and was doing, at the University of Michigan, and was doing some research on insects, and Viraj actually got a National Geographic grant to do work on a coastal Kenyan community. He's from Kenya. That has been destroyed by trawling and overfishing. So our mutual passions, we kind of came together and started working on this idea, and we're able to put together a really awesome team behind this from all sorts of different backgrounds, not just interdisciplinary, different gender backgrounds, different socioeconomic backgrounds, and really tackle this problem from a holistic view. We brought on Maya and Elias, who are working in various capacities, both going to Brown University. I just graduated from the University of Michigan Ross School of Business, and Viraj also goes to Brown. We've also been able to put together an incredible group of advisors, some leading students, industry experts, business professionals that are helping to support us. And we're also extremely excited that we just got our first customer, Live Oak Brewery in Austin, Texas. They're producing just over 500 tons of organic waste per year, and we plan on taking a portion of that and diverting that with our first prototype and on-site container at their facility. Something else that's extremely exciting is that we found a buyer of our larva. Unfortunately, I can't disclose their name, but they're an organic feed retailer, and why we're so excited is because we're actually able to extract additional value from this product by pushing our social mission. So this organic feed retailer's core mission is to create alternative protein to replace soy. So they've already found an existing customer base willing to pay a premium to to create more sustainable protein alternatives. And we're hoping to tap into that existing network of over 200 retail branches and a booming e-commerce division. And this is the product that we're creating. While we have a cost advantage, we do plan on differentiating based on the social mission and values that we bring to the table. So we plan on pricing similar and trying to create a brand around this. We're also really excited that we've had a lot of support and progress around the way. We've raised over $200,000 in completely non-dilutive funding from winning some of the world's most prestigious food security and innovation competitions. We've also built 2 fully functional prototype facilities, one at the University of Michigan and one at Brown University, where we're currently taking brewers' grains. And as I just mentioned, we've just formed these concrete relationships to actually move this to a commercial scale where we can test the model and pilot in the real world, which is extremely exciting. Finally, I just want to leave you guys with the facts, and I hope that I can get this across. We're extremely passionate about what we're doing. And we really do genuinely believe that our innovative approach to these huge problems that people have tried to tackle before are truly unique and value creating. And we think that we have the potential to totally transform the way that people look at organic waste for decades to come, and while also changing the way that we fuel our agricultural system. Thank you very much.
Nice job.
Thank you, I appreciate it.
So what do you do? Do you just like go for a drink or whatever and then say to the owner, hey, can I grow black fly larvae at your place?
It's actually so funny. So the way that we got started was we were going to Austin. We emailed like 20 or 30 breweries, only got one response, went to the brewery, and the person that we were meeting with didn't even show up. So we waited there for 2 hours,
But
had
it
a
was
couple
brewery,
beers.
so yeah.
As we were about to leave, she showed up, and we got introduced to her and got kind of involved in the Austin brewing space, and that was kind of how it developed. But yeah, it's really just going to these places, having a drink with them, and it's cool because we're interested in what they're doing, and they're interested in what we're doing, so we're able to talk about cool stuff together.
Right. But you said you did actually look at different industries and just happened to land on this particular industry.
Yeah, absolutely. Right? So various different like meat processing, dairy processing, even municipal wastewater treatment were all things that we explored. I actually grew larvae on sewage waste in my dorm room. My roommates weren't happy about that.
I'm sure others did that inadvertently. They grew larvae on there.
Yeah, I think everybody's doing it, but I was the only one to bring it back to my room.
Do it intentionally.
Yeah.
Right,
Yeah.
So what's it been like? So you were in other competitions and you were successful there, and you're using kind of building some momentum with your project.
Yeah, so we feel really fortunate in that there's a lot of support around what we're trying to do right now, and that's really how we're trying to finance. You know, we're a bunch of students that are very passionate about what we're trying to do, but don't really have access to traditional financing mechanisms because we're so young and haven't really done much before. So we've really just been grinding out these competitions, and it's so cool to be able to do one in my home city where I can sleep in my own bed. And hopefully my mom can come later today if she picks me over my sister. So we'll see.
Right, we'll see. We'll see.
Yeah.
So how did you all get connected initially?
So as I just mentioned earlier, I met Viraj through the Doors to Conservation Scholars Program. Right. And then from there, we've just been talking about our idea and finding people that are passionate and can really fit into certain areas. And that's kind of where how we've been building our team out.
That's great. Doris Duke, Wege, these are great philanthropies in the United States that we're all very lucky to have in our midst.
Yes.
Now they really have a lot to talk about here. So what has been one of the bigger challenges for you in, sort of as far as you are in this project so far?
Yeah. So I think the biggest challenge was kind of navigating our way through where we want to target. I mean, it's such a huge problem. You really have to try to focus down a specific area. So I think that was the biggest challenge that we were facing, trying to identify where we can really move this first, who could use our solution. Yeah.
Great.
Yeah.
I think they're ready.
Okay.
All right.
Whatever you think. Yeah. Thank you.
Whatever you think.
Yeah, I'll start again. Okay, thank you. So you had mentioned that. So it was maybe a two-part question.
Yes.
There are 36 million tons of food waste, and I'm wondering how much of that is viable for the black soldier fly. So you're picking a very homogeneous, clean food source. There's obviously a lot of waste out there that is not like that.
Yeah.
So what percentage of this is available for you to tap in now?
I think if we could go back to the presentation, I don't know if that's possible or not. So the numbers are on the slides. I don't have them memorized, but we've identified the amount of the market size within the brewing industry at about $300 million. that's the organic waste in that industry. And you're right, it's a little bit difficult because we would have to essentially create a new product to move into other industries. But we do think that the scale of the industry is big enough right now, just because there's so many large food and beverage processors, not just like beer producers, but other people that are producing consistent homogeneous waste that we can move into. Did that answer the question?
Yeah,
Okay,
it sounds like you need consistent homogeneous waste in order for this to work, and that's where I wonder how. I know it's a complicated answer, but
so the reason that we picked breweries is because you need consistent homogeneous waste, but it's easy to make non-consistent, non-homogeneous waste like that by adding like a hammer mill to the process. That just adds an additional level of infrastructure investment, and we're trying to keep it as low capital intensive as possible for right now. So these other companies that are acting as used waste managers, they've just invested in the infrastructure necessary to grind and process all that waste. We're trying to avoid that for right now, but you can move into all these different waste streams and just add another pre-processing step.
got it.
Yeah.
And one follow-up, and I don't want to hog the time for my
Yeah,
fellow
of
judges,
course.
but I had a memory of this actually being talked about in the news. It was a magazine. So Inc. magazine, this very idea was proposed 2014. What makes you different? What makes you better?
Yeah, so there's other people doing black soldier fly, and this is what I really feel most strong about, is that this approach, it wasn't on-site was on-site black soldier fly. Okay, well, I think that I don't know anybody who's doing that right now. So that's, if somebody else is doing that, then that would be really similar to what we're doing. I think what makes us unique, particularly if there was another company doing that, is our focus on microbiology, trying to pre-process the waste using natural inoculants, lactobacillus-based bacteria that emit a cellulase and a halocellulase, that you can essentially convert some of those indigestible starches into glucose that the black soldier fly can then access. So if there's somebody trying to pursue the same model, I'd say, hey, this is how we can differentiate from them. But I think just the on-site model is something that's really interesting to figure out. Another thing, and not to take too much time, but is that we're trying to, I think that's the biggest thing. I don't want to take too much time. Yeah.
Can I ask about the on-site element?
Yeah.
Presumably, well, tell us about what type of management is required, how much time commitment there is there, and as you scale, one hopes, what does it mean in terms of how you can operate across the country?
Yeah, so that's the biggest, I guess, parameter that we've kind of been designing around, is how do you keep this extremely low labor and extremely easy to manage. So it's really just a shift from how they're currently managing waste to our solution. And that's something that we're still developing. We do still need to get the labor intensiveness down, and that's why we're really trying to incorporate mechanical engineering and electrical engineering to try to mechanize and automate some of those processes, because the majority of the labor is just in distributing waste to the buckets for right now. We simply don't have the capital right now to really invest in a solution to do that for this prototype when we're really not even sure what would work. But that's what we're working towards. And our goal is to keep it less than 30 minutes per day, which from our interviews with microbreweries is about more or less what they're spending on waste management right now.
And who will do that in Texas?
Who will do that in Texas?
Who will do that in Texas with your first customer?
We will. So it's going to be us on site. So we're going to be taking the roles of the brewery. So it's a little unique situation that we're not implementing our exact model that they're not managing. We're managing it, but we're hoping to learn from them.
Yeah, I just want to, when you talk about the containers, I mean, I love your idea.
Thank you.
Actually, I'm using containers as building materials down in Miami. Are you using used shipping containers?
Yep.
And
So
retrofitting them?
yeah, so we're just buying used new shipping containers and retrofitting them. Yeah, putting an HVAC system on it. Yeah.
Okay. All right. Great. Actually, you had a good question.
Yeah, I had a question about the black soldier fly larva life cycle.
Yes.
So I've heard that it can be challenging to get them to reproduce so that you have a self-maintaining population, and I'm wondering what your solution is for that.
So our first solution was we wanted to handle the breeding ourselves. We found it extremely difficult. We were getting research support, and we still found it very challenging. So what we've actually done with the shipping container, and while we're able to implement this in such little space, and this is what I was going to add on to him, so I'm really glad that you asked, but we actually outsourced the breeding. So there's people that sell eggs. There's a market for buying eggs. So we don't want to occupy that part of the process. We really want to focus on a solution for existing waste management. So we don't even deal with the breeding. We buy our eggs pre-hatched. We put them in. They come out. then they're done. That we really want to handle just that isolated process. We don't want to be a biological company. We want to serve waste management. Yeah.
Because of the climate factors and the temperature outside, where will this work? I mean, I can see it working in Texas. It's warm. You just mentioned that there's an HVAC system in the container. Like, where can this work and where can it not work?
So what's so cool about the insects, this is kind of what I geek out about, is that when you alter the density of the insects, they actually self-control their temperature. So if you put too many insects within a container, they'll actually overheat and kill themselves. So what you're able to do is control the density uniquely depending on the situation, and they're extremely hardy animals. So I was growing them at Michigan, wanted to kill them, so actually just left them outside in sub-freezing temperatures for 3 or 4 days, brought them back in, and our lab space was infested with flies. So they weren't very happy about that, but the insect is very hardy. We're trying to regulate the temperature between 70 and 100 degrees, but really lots of the management is just done by the insect itself. Yeah, the temperature management at least.
So you're from Grand Rapids.
Yeah.
There's Founders Brewery right down the
Yeah.
street. Are you gonna prototype and pitch here in Michigan, especially because I have read and heard the same thing that in these sub-zero temperatures, managing that could be really difficult.
Yeah, so that's a reason why we're moving to Texas for now, is to keep our heating electricity costs down and try to just prove the model, keeping factors as sure as possible. We would love to move it to Grand Rapids. We just met with Start Garden to see how we could potentially bring this idea to Grand Rapids after we've proved the model a little bit more in Texas. So there would definitely be more challenges regarding the climate and the temperature, but I'm not sure that would be the big. So I think that we can move this to Grand Rapids, and that's certainly my goal, because this idea works best in the city where there's lots of microbreweries. You can put a container on many, and then just collect them all from one central location. Yeah. So.
In your final submission, you said that eventually the food and beverage company would pay for the installation themselves. So tell me about the profit split of the food waste sale.
So that's something that we're really exploring, and really, to be completely frank with you, we're really don't know what the best way to approach that is. You know, there's lots of different financing models we can use. We can try to get a microbrewery to pay for it, pay a fee up front to help our cash flow situation, and then distribute larger payments to them, or we can try to cover the cost if we think we have enough money to do that. But we're really trying to understand the best way to do that, and we don't have the answer right now. Right now we're really hoping that we can finance the construction of the container ourselves to encourage widespread adoption, and then pay a lower fee to them. But whether it's paying them a portion of the profits or paying them per ton of waste that they give to us, we're really exploring these different options. That's what we're hoping to learn through this pilot a little bit better. Yeah. Yes?
Where can we buy a Kulisha t-shirt?
So, kind of embarrassing. My mom made these for me. So they're not for sale yet. Very nice of her. But yeah, it keeps me from having to wear a suit, so I'm happy about that. But,
so, if I may, another question: have you extensively modeled the costs associated with this operation? Because it sounds like you're operating at a loss, because you've got humans there who are expensive. You've got an on-site physical plant. You've got electrical costs, and then I'm wondering, would it work here in Michigan, where now you've got to transport these larvae to a fishery?
Yeah.
Presumably, or to an organic food company that can then process it. Can you tell me a little bit more about that?
So right now, we're operating at a loss purely because we have to pay. I mean, labor is a huge fee when you really have few other costs, and like us having to pay ourselves is the biggest cost. But when you transition to, there's already somebody being paid to manage waste, and they just have to fill a little slightly different role. I wish I could show you, but there is a cost analysis that we've done, and it comes out to be about $1,300 to $1,400 per ton is the total cost of producing 1 ton of black soldier fly using this container, including processing, marketing, transportation, all that. So it's really low cost, and we do need to figure out how we can continuously decrease the labor required. That's, again, I really want to stress, that's the biggest parameter that we need to understand more and we need to learn more about. But it is very cost feasible, yeah. Cool. Thank you very much, guys.
Thank you. You good?